Viewers, I am Pranesh. Today I will discuss by this example, this general example. Now you will see. See here I choose this molecule. This is called this is one ester. So here two keto group is there. No, two keto means this is all are ester. This is one ester group is there. You know, one is keto group is there. In ester one keto group is there. In keto also keto. So yeah, I want to reduce this keto group in presence of this keto group. So if I use some reducing reagent or some nucleophile, so that time what you will do, you have to protect this keto group, not this. So for this keto group you have need some reagent. Okay. So that reagent after the reaction, after the reducing of this keto group, you have to get the previous this one. So first I protect this one and I use some reagent to reduce this one, and after that I will get. So see, I use this is called ethylene glycol. Ethylene glycol is a good protecting group of keto. Okay, so it will form this type of acetyl moiety. It is called acetyl. So this type of in situ I will show mechanism further. And then I use this Grignard reagent, phenyl magnesium bromide, and this phenyl will attack there and this will come. Okay, then its function is over. This ester function is over. Here is two equivalent you can use, because here is ester, no, that first it will attack there, then one this will come, this will come again like so. This alcohol will come. I use this keto to alcohol, then I have to remove this protecting group. Then I use acid condition to remove this one and get this one. Okay, so see, first starting from there you get this one. So if that's why this is the importance of protecting group. You understood, na? So now I will go to the different functional group, protecting group. Hi friends, now I will discuss about the some protecting group. So here I choose the functional group as a NH2 group. You see, na? NH2 means amine group, amine protecting group. If any protecting group is there, a functional group is there, in that amine also there, keto also there, so alcohol also there. So if you want to protect only amine group, so what will be the reagent that you should know, and after protection what is called, that also remember, and after how can you deprotect this protecting group, how do you protect this protecting group from this functional group, you should remember. So three things you should remember, just you can see there. See, this is NH2, no? NH2 protecting group. I see one, this is called BNG group, or you also call CBZ. You already know, you already heard this reagent. This is called CBZ group, CBZ, carboxyl benzene, it is called. So you also simply remember it is called CBZ. So see, this is one acid, this is called proline. You know already this is proline, this is acid. So I want to protect this one, this amine. This is also amine, no? This is secondary amine. So you want to protect this one. So what do you do? This is the protecting group. This is CBZ group. Benzoyl chloride. BNO. You should remember this is benzyl group. Benzyl group means this group. BN means this. So you use triethylamine and this. You should remember every step. Then that base will take the proton from there, and then it will attack there. It will go there and it will back and it will attack. So this will form this portion. This portion is called CBZ. Should remember CBZ. Every time many net question paper, this CBZ also there and this group also there. You should just remember these things. And you go to after that reaction, if you want to some transformation here, because I not done any transformation. So after you want to remove, that you should remove. How can you remove? H2 palladium. If you use H2 palladium hydrogenation, that time it will remove. But if something you want to do there, easily do there. Hi friends, now you see the another NH2 protecting group. Okay, here you see I use this acid. This is amino acid, no? In deuterionic form. It is NH3 plus, and see it is deuterionic form. Okay, so I want to protect this one, not this. This carboxylic acid not group, and NH2 I want to protect amine. It is deuterionic form. Actually it is like that only, H and here only NH2. Okay, so it is here I introduce new reagent. It is called BOC2U. BOC2U is called BOC group means tertiary butoxy-carbonyl group. What is called tertiary butoxy-carbonyl group. So if you remember both of them, it is called BOC. In exam they will give like BOC or tertiary butoxy-carbonyl group or structure. So what is the BOC? BOC is this one. No? Triethylamine take the proton from here and it will attack this tertiary butoxy. You want to write this structure, no? This is BOC group. BOC group. Okay. NH2CuO-TBU. It is BOC. BOC means like that. I want to write this. This TBU. This is called O. This O. This is called O. This is OTBU. So this is this BOC. It is called BOC2O. Understood? So one question will come here. If you NH2 means if NH minus will like that R, it will come here and it will go. Then it will come. One question will come. So it is BOC. Then diluted HCl or trifluoroacetic acid is used for deprotecting. So I actually not conversion. How do you protect? Previous method you also saw CBZ and this also. So see here BOC2 is like that and this diluted HCl and D. So you can ask me why you are use their deprotecting condition hydrogen palladium, not acid. Here see the deprotecting reagent is acid. In acid condition it will automatically deprotect. So this is the difference and there is benzyl is there. That's why we use hydrogen palladium. Now I will discussing about the another functional group which is called OH protecting group. Okay, so previously I showed two examples of NH2 protecting group. I think that's sufficient for you. If anything further needed, I will give. Here you see one new protecting group. You should remember these things. I think it will come or not come, but you have to understand for understanding purpose. I have to give. Okay, here see this group I agree. Here already alcohol is attached. Okay, so this is called benzyl trichloroacidamide. See. So trichloroacidamide. No, if any benzyl alcohol, if you are any alcohol is there, so this group you have to attach. It is attached by see this reagent. If it is like that, if any reagent is like that time it will use any benzyl alcohol is there. Benzyl alcohol is there minus and it will attach there and it will go. It will come. It will go. So that will form. That will form. So this is benzyl trichloroacidamide. It is called triflic acid. No? This is triflic acid structure. TFOH. Sometimes this will give, that will give. So you have to remember which one they will give. Same condition, it will protonated and it will cleave here. So this will form. So you remember again, it will come from this one, and this is alcohol protection. That alcohol protection is depend on this. So see, OH is many protecting groups are there. So depending on their conditions. If acid sensitive protecting group is there, hydrogen palladium protecting group is there, only single protecting group is there. Because if it is one all means one hydroxy is there, one type of protecting group. If it is two is there, the different type of protecting group. So OH is a versatile application. NH2 is single NH2 is there, that time it will easily protect. No? Now you have to see. This is another protecting group. It is called para-methoxybenzyl ethers. It is also called PMB. Okay, so it is called PMB. Okay, para-methoxybenzyl ether. So if you taken any alcohol OH protection group, you give PMBCl. What is PMBCl? This is PMBCl. PMBCl structure is like that only. Yeah, I write like this one. This one is like that. This one is like that. No? Para-methoxybenzyl chloride. This is para-methoxy PMBCl. So this is para-methoxybenzyl chloride, triethylamine and DMAP if you use, and that time you will get this one, this alcohol part, and this is the remaining PMB part. So that is one type of important. So it is, if it is any group, it is hydrogen palladium sensitive. That time you will to deprotect by this DDQ. DDQ already you know, this is one kind of oxidizing agent. DDQ in methane diGCM, it will deprotect. It is also deprotect by this. So this is the main condition, because in that benzyl condition is hydrogen palladium. Be any other hydrogen palladium sensitive group is there, that time you will do DDQ this condition. So you just remember this thing, this DDQ it will deprotect, and what is the PMB? PMB is this one. So now I will go to another example. Now you will see the another type of protecting group. Which protecting group? It is called TMS group. Different TMS or TBS type group is there. Means silyl group, silyl containing group is there. Silyl is there, silicon is there in this. So now you will see. So here I put this TMS ether. No, this is TMS ether means if you TMS type group means silyl type group, if you form ether, so it will form C ROH I2 and trimethyl silyl chloride I2. So it is called TMS. Now how it will form? OH base will take proton from there, O minus will from that, O minus will attack and it will go. And this is this so this will form silyl ester will ether is formed because RO. So how can it remove? You will use strong acid condition this group for only for cis silyl ether or F minus source means fluoride ion source, because fluoride ion source is very important. That fluoride condition, ion source condition, it will deprotect. So this is good. So here it will come because it is minor. This major deprotection reagent is F minus. So here you see I wrote this one and I use tertiary butyl dimethyl silyl chloride. It is called TBDMS. Okay, so it will call TBDMS or it is a tertiary butyl dimethyl silyl ether. This is very important, very good OH protecting group. Okay, it is less labile. Less labile means it will not go to in acid condition. It will go to acid condition, but it will not go acid condition. It will only need fluoride source. Hi friends, now I will give the another silyl group introducing as a protecting group in OH. Okay, so here you see RO. It is called hexyl dimethyl silyl ethers. It is not a common, but sometimes they will confuse. It is like that a previous TBDMS. That is there, no? Like that only it is like that. So sometimes you will confuse because why it is called TDS. TDS is little bit different. Modification is there. Hexyl dimethyl silyl ethers. It is called. This is the group. This is carbon. This carbon. This is silyl dimethyl. So if you like the base condition, so you will get this one. This is called TDS. Now I will introduce another different OH protecting group. It is also is a silicon family. So this is called tertiary butyl diphenyl silyl ether. That butyl diphenyl, not dimethyl, diphenyl silyl ether. It is called BPS group. It is RO because it is called BPS. You also call it BPS. Okay. So you do alcohol and this you have to do, and imidazole it is there. Triethylamine dimethyl is there. So you will get this. Then you have to deprotect by this fluoride source. This is HF pyridine. It is very strong fluoride source, very strong, and it is little bit mild, but it needs more. See, this is very strong protecting group, means not easily available. Now, if you use strong acid or normal fluoride source, less amount of fluoride source is there, that will not affect. This kind of strong fluoride, the hydrogen fluoride is a strong acid as a fluoride source. So that you will need because it is more than strong the previous all of. So this is you got ROH. So finally you will got. So you would remember this is different kind. This is TMS, TBDMS, then this TBDPS. Now I will give another OH protection group I have to introduce. This is called acetals. If you make OH group as a acetals, means one carbon in between them and two oxygen group is there. It is called acetal. First example in the beginning of the video I gave this one type. Now it is a acetal. So what is the acetal? That you have to know. So this you have to see this example and you have to understand. Acetal as a form of acetal. See here I use acetal which is protecting group. This is called tetrahydropyrenyl ethers or called THP. This is called THP. This moiety you see na. This moiety you call THP. Tetrahydropyrenyl. Tetrahydropyrenyl. It is called DHP. It will transfer to THP by. So this is acetal. No? This will form. This is the final product. One carbon is there. So this is called acetal type. So this is PPTS. PPTS is this one acid. This is called PPTS. So this acid source is there in between. If it is get acid, so what will take? It will take and it will come H plus, no, and it will form. Then OH, then OR, O letter there. So this will form. No, you know. First step what? In acid PPTs, when you give to PPTs, then it THP, THP ether. OR is no, it is called THP ether. But this THP ether is common. You see some books. There are many examples. I will discuss also next video on THP example. So it is one disadvantage. Disadvantage is there if adjacent carrier center is there. So here another carrier center will form. So there is a carrier center problem will there. I will discuss next video. So this is the THP, you know. Now I will go to the another. So see here Ac2O, acetic anhydride, you already know these things. Triethylamine and DMAP as a catalyst as a base. So you will get this OAC. So this OAC you have to use any basic condition, you will do protect and it will give the OH group. So if other condition is there, so after that you will do protect by base condition. So that's why I wrote this basic condition. Understood? Here you have to choose this type, and if you have to form to acetic anhydride to form this type, and you have to go to OAC and you have to deprotect. So that is the main. This is another OH protecting group. It is called as a para-toluene sulfonic ester. As a you have to protect like a para-toluene group, UTS like that. So if it is called RTS group, tosyl, yeah, it is called tosyl group. So it will form as a ester form. So it is called para-toluene sulfur ester. So it is tosyl, it is called TS. So there is a condition if you talk para-toluene, tosyl you know no, para-toluene sulfonic acid. Para-toluene sulfonyl chloride is called tosyl. You have to see in your net if you don't net because basic only. So ROH, if you tosyl chloride is there, so if you use to pyridine and this copper sulfate conditions, so that will give this one. So there is a and if you remove by only metal source, only simple metal source, UTS is there, only metal source. There is another condition is there, hydrate condition. I will see. I will give to the and this is sodium as a metal condition and you will deprotect. Understood na? Your tosyl, this is tosyl group. This tosyl will come from tosyl as a different source and you go to ROH. You understood? Now I will give two examples to removing the tosyl group by lithium. Lithium triethyl borane. This is one source for reducing this one. So you have to understand this. Remember this both example. This reduction reagent function to remove this one, or this group is removed by this reagent. So this is one of the important two examples. It is common in some books and some net exam I saw. So that's why I put it there. You have to remember these things. Okay.